Good day everyone. We are Group 2 from STEM 2301 presenting our research study about effects of SODIS PTSC in disinfecting groundwater using different water bottles in Palawig, Zambales.
Background of the study. Access to safe drinking water remains a critical challenge to local communities of Zambales. According to Nawiki et al. 2021, high levels of microbial contamination such as Escherichia coli or E. coli faces numerous environmental stresses that pose significant health risks. Mining activities have led to significant concerns about water pollution, DNR 2016. Currently, there are several methods for disinfecting municipal water supplies to improve its water quality. There are generally three common types of disinfection techniques, including chemical, radiation, and heat. Solar water disinfection, or SODIS, is a method that utilizes sunlight to disinfect microbial pathogens in water, such as Escherichia coli. It offers a simple, cost-effective, and environment-friendly water treatment solution. This method harnesses ultraviolet and heat to eliminate or inactivate various pathogens in drinking water. Firi et al. 2023.
As Betty et al. 2019 explained, the parabolic throw doesn't directly increase radiation, but enhances thermal energy, allowing water to heat up faster. This makes solar disinfection SODIS about twice as efficient by reducing the required disinfection time. As the Varsoglu 2015 found, the type of bottle also plays a key role. Colorless bottles are the most effective because they let in more sunlight and UV rays, improving the disinfection process. Combining these factors makes SODIS more efficient.
For the purpose statement, the intent of this study is to observe the effectiveness of using the materials polyethylene terephthalate or PET, glass, and polycarbonate bottles in solar water disinfection or SODIS, in terms of using parabolic throw solar collector or PTSC, and Escherichia coli or E. coli count. The study will be evaluating the efficiency of disinfecting groundwater in Barangay Bulawen, Palawig, Zambales. The researchers will analyze the E. coli counts by a descriptive quantitative study. This study will contribute to additional information regarding the materials under SODIS in the Philippines.
For the research questions, number 1. How does the different duration of sunlight exposure using SODIS PTSC in PET, glass, and polycarbonate bottles affect the microbial disinfection of groundwater in Bulawen, Zambales? For number 2, how does varying temperature affect the performance of SODIS PTSC in PET, glass, and polycarbonate bottles? And for the last, what is the turbidity level of groundwater in Bulawen, Zambales after the use of SODIS PTSC in PET, glass, and polycarbonate bottles?
The study aims to provide alternative water disinfection method that influences and encourages the usage of environmentally affordable materials. It provides valuable information to environmental advocates by promoting sustainable development goals. It contributes to ensuring clean water and sanitation, SDG 6, supporting good health and well-being, SDG 3, and encouraging responsible consumption and production, SDG 12. Furthermore, it provides rural communities an access to clean water, which is usually limited. This study provides a low-cost solution, an affordable alternative to expensive water treatment, still promoting health improvements in water safety practices. Lastly, this study benefits researchers and academics focused on water disinfection and public health through assessing various bottled materials for SODIS, which can lead to future research and innovation involving collaboration or development of better water disinfection technology. Furthermore, it advances the academic and science understanding of sustainable and accessible water disinfection techniques. This study aims to evaluate the effectiveness of SODIS PTSC to disinfect groundwater from Barangay Bulawen, Palawig, Zambales. Specifically, it studies how PTSC system enhances the disinfection process in different bottled materials, PET, glass, and polycarbonate. The study did not focus on direct comparison of the three bottled materials, but rather focused on assessing the overall performance of the SODIS PTSC in microbial disinfection. A descriptive quantitative method was used to measure changes in E. coli contamination and physical water quality before and after SODIS. This study was conducted by NUNS Grade 12 STEM students with laboratory professionals from the Philippine Institute of Pure and Applied Chemistry and Hydrolab Company, assisting in laboratory testing to ensure the results' accuracy.
For the conceptual framework, SODIS PTSC, where the parabolic trap solar collector or PTSC, explain how different types of bottles are utilized during the disinfection process. PTSC design ensures that more sunlight is directed toward the bottles, regardless of their placement due to its parabolic shape. PET, glass, and polycarbonate bottles serve as water storage during the disinfection process to see the water quality in developing SODIS method. Water quality will serve as the source for assessing both temperature, E. coli counts, and turbidity. These measurements will enable researchers to evaluate the effectiveness of solar water disinfection in parabolic trough solar collector method. Additionally, temperature are monitored to assess whether the exposure to sunlight from the PTSC design is sufficient to remove microorganisms, especially E. coli counts, through the disinfection process. This study utilized a descriptive quantitative approach to evaluate the effects of solar water disinfection integrated with parabolic trough solar collector, using 3 different container materials in disinfecting groundwater through the SODIS method. It seeks to provide evidence on how each material affects the disinfection process, considering factors like microbial reduction, duration of sun exposure, temperature, and turbidity. This research aimed to determine whether the types of container materials were efficient and consistent in its result.
For the research instrument, first is the solar water disinfection, SODIS. We've made the parabolic through solar collector or the PTSC prototype model to evaluate the effectiveness of PET, glass, and polycarbonate bottles in solar water disinfection. Next is the total coliform testing. We've used the following. First is the multiple tube fermentation technique or the MTFT. It is a process of testing that is being utilized to furtherly check the active coliform bacteria in the groundwater to determine the most suitable water content for laboratory applied testing. And it has 3-stage procedure: presumptive stage, confirmed stage, and the complete stage, to ensure the accurateness and effectiveness of water, which is a common procedure to detect coliform organism. Second is the enzyme substrate coliform test or the EST. This kind of testing is a rapid procedure to test and detect coliform bacteria with enzyme-based reactions in producing and detecting enzyme bacterial organisms. For the turbidity testing, we've utilized the nephelometric method. This method was used for turbidity levels to assess the clarity of water and measure the light scattered by suspending particles. Lastly, the monitoring of water temperature. We've utilized the digital water heat thermometer for temperature monitoring and to track the levels of heat.
The data collection procedure of this study consists of 3 parts: the process of making the PTSC, preparation and sterilization of the bottles, and the SOTIS method. Progress of parabolic throw solar collector. First is to measure the materials that are needed. This is done to make sure that it has an exact measurement. Next is to cut all the materials with the exact measurement, then drill the already cut pipes to connect the crown pipes to one another. Using the metal polisher, clean the aluminum sheet to make it more reflective. After cleaning the sheet, drill it to the pipe, making sure that the measurements are all aligned, and then connect the base of the model and add glue to its connector to stable it. Lastly is to place the bottles in the model and test it using a laser pointer to see if the light passes through the center. Bottle preparation and sterilization. Figure 3A shows how PET bottles were sterilized. Using a candle, light it in a working area. Make sure to empty out the Coke bottle near the flame of the candle. Rinse the bottle and its cap with the distilled water. Do it for 2 to 3 times, and then close the bottle with its lid. Figure 3B shows how glass bottles are sterilized. Ferreira et al. 2021 shows that in the bottling plant, the starting point for the reusable glass bottle is the cleaning process with hot water and chemicals required to clean and sterilize the bottles as well as to get rid of the labels. First is to boil a distilled water at a temperature of 50 degrees. Mix the boiled water with the distilled water until it's warm. Soak the glass bottles to preheat it to avoid cracks, and then pour boiling water onto the glass and let it soak for a few minutes. Finally, empty the glass bottle and then close it. Figure 3 shows that the polycarbonate bottles was sterilized by boiling a distilled water at a temperature of 50 to 70 degrees. Pour the water onto the bottle and shake it for at least a minute, and then pour out the water and add new boiled water along with a gentle soap. Lastly, pour out the water with soap and rinse the bottle for 4 times with distilled water. Pre-implementation. Figure A shows that the groundwater samples are collected in Barangay Bulawan, Palawig, Zambales, 2 liter per bottle. The groundwater samples are sent to the laboratory. The samples for coliform testing is sent to the Philippine Institute of Pure and Applied Chemistry or PIPAC, while the samples for the turbidity testing is sent to the Hydrolab company. Both tests are made to get the results of the non-disinfected groundwater sample. The method used for the 2 tests are the multiple tube fermentation for coliform test and nephelometric method turbidity test. Implementation proper. Figure B shows that after collecting the samples, the groundwater undergoes the SOTIS method. Each bottle contains a 2 liter sample. Samples are collected in 3 different time spans for the different containers used. This is helpful in terms in getting much clearer results. A temperature test is conducted while using a digital food thermometer. After 4, 6, and 8 hours, the researchers gather the temperature of the samples of the different bottles. The results of the temperature test are helpful for the researchers to determine the relationship of the E. coli and the temperature and how the temperature helps to disinfect the E. coli faster. Post-implementation. Figure 4C shows that after hours of SODIS, the now disinfected groundwater sample are sent to the Hydrolab company to undergo coliform test and turbidity test. The method used for the test are enzyme substrate coliform test and nephelometric method for turbidity test. Based on the standard that the Department of Health have posted, less than 1 E. coli should be present in every 100 ml sample, and the maximum allowable level or MAL for the turbidity should be at 5 nephelometric turbidity unit or NTU.
For the research sample, the researchers gathered the water needed for the experiment in Barangay Bulawin, Palawig, Zambales. The chosen area has a notable groundwater source that contains E. coli. Coliform and turbidity tests were done through private laboratories such as PIPAC, Philippine Institute of Pure and Applied Chemistry, which is where water turbidity was tested, located at PIPAC Building, Quezon City, Metro Manila. And Hydrolab, which is where the coliform test was conducted, located at MNRI Building, Mindanao Avenue, Quezon City, Metro Manila. Both are reputable laboratories chosen to ensure the accuracy of results and for the available specializations or services in water testing.
For the data analysis, the researchers used descriptive analysis to provide a detailed explanation of the data, which includes changes in E. coli counts before and after the SODIS PTSC method, the different water temperature results, and the turbidity levels to evaluate the efficiency of the SODIS PTSC method. This analysis helps the researchers evaluate the quality of different storage materials and ensuring water safety during disinfection and to ensure the efficiency of SODIS PTSC.
For ethical consideration, the resultant communication is crucial to carefully evaluate and investigate the process of the study throughout data gathering. Safety measures are done, being wary of others and safety in all aspects. Integrity plays an important role, required to be respectful, honest, and upright to avoid misunderstandings. And most importantly, for the success of the study. Objectivity is done, where researchers have maintained professionalism, ensuring that the results from the experimental data analysis, and interpretation of the experiment remain unbiased to ensure that the information gathered is legitimate and the results are accurate.
Table 1 presents E. coli counts in groundwater from Zambales before and after solar disinfection using different bottle materials such as PET, glass, and polycarbonate under sunlight with a parabolic throw solar concentrator. Initially, all samples had more than 8.0 mpn per 100 ml E. coli count, indicating high contamination. After disinfection, PET and glass bottles consistently reduced E. coli count to less than 1 mpn per 100 ml within 4 to 6 hours, meeting the Philippine national standards for drinking water. However, one polycarbonate bottle showed 2.0 mpn per 100 ml at 6 hours. By 8 hours, all bottles achieve safe levels. These findings confirm PET and glass bottles as effective choices for SODIS, while polycarbonate showed variability.
The graph shows the results of a study measuring the average temperature and E. coli count, most probable number per 100 ml after 4 hours of sunlight exposure using 3 different water storage materials: polycarbonate, PET, and glass. The recorded average temperature across all materials was 43 degrees Celsius, which stayed consistent throughout the entire exposure period without any noticeable variations in temperature levels. After 4 hours, all 3 materials successfully reduced the E. coli count less than 1. The similarity in performance across polycarbonate, PET, and glass bottles suggested and demonstrated comparable results in water sanitation, where the data indicate that regardless of whether water is stored in polycarbonate, PET, and glass bottles, the result will be entirely the same. The graph illustrates the disinfecting efficiency of SODIS PTSC at 38 degrees Celsius over a 6-hour period, comparing 3 materials: polycarbonate, PET, and glass. PET and glass reduced E. coli to less than 1 most probable number per 100 ml, achieving successful disinfection, while polycarbonate showed the higher count of 2.0 most probable number per 100 ml, indicating lower effectiveness. While all three materials significantly reduced E. coli, PET and glass are more effective for complete disinfection within 6 hours.
Figure 7 examines the effectiveness of solar water disinfection with parabolic flow solar collector at 37 degrees Celsius over an 8-hour period. The study confirms SODIS PTSC effectively reduces E. coli below 1 mpn per 100 ml in polycarbonate, PET, and glass bottles. The recorded data include E. coli count reductions and average water temperatures within each bottle type throughout the exposure period. The findings indicate that the E. coli count was initially greater than 8.0 mpn per 100 ml, signifying a high level of contamination. However, after 8 hours of sunlight exposure, E. coli levels dropped to below 1 mpn per 100 ml across all three materials, demonstrating successful microbial reduction.
This figure represents the turbidity results of the non-disinfected or untreated and the disinfected or treated groundwater samples for Barangay Bulawen, Palawig, Zambales using 3 different bottle materials. The turbidity test shows the clarity of groundwater samples before and after undergoing the solar water disinfection with parabolic trough solar collector or SODIS PTSC method. The method used for both the before and after SODIS is called the nephelometric method. The results are then based on the standard of the DOH AO 2017-0010 Philippine National Standards for Drinking Water of 2017 to see if the water passed the standard. The maximum allowable level or MAL for turbidity is 5 NTU or nephelometric turbidity unit. And the non-disinfectant groundwater sample resulted at 0.30 NTU and stated in the study of Nuanco 2024, to ensure the effectiveness of SODIS, the turbidity of the water should be less than 30 NTU. The results show that over a 4-hour span, the turbidity level of the PET bottle increased by 0.25 NTU to 0.55 NTU, showing an increase within 4 hours under the SODIS PTSC method. On the other hand, the turbidity level of the glass bottle decreased by 0.10 NTU and the polycarbonate bottle decreased by 0.15 NTU. After 6 hours under the SODIS PTSC method, the turbidity level of the PET bottle is 0.30 NTU, same as the result of the non-disinfected water, while the glass and polycarbonate bottles both decreased by 0.10 NTU, reaching a level of 0.20 NTU. After 8 hours, the results remained consistent with those results at 6 hours with no significant changes in turbidity levels, meaning that all treated water samples, regardless of bottle material, maintained turbidity levels well within the Philippine National Standards for Drinking Water's acceptable limit of 5 NTU or nephelometric turbidity unit.
For the conclusion, the summary of findings is that after 4, 6, and 8 hours of sunlight exposure, most bottles achieved an E. coli count of less than 1 mpn per 100 ml. However, one polycarbonate bottle exposed in sunlight for 6 hours showed an E. coli count of 2.0 mpn per 100 ml. Average temperature for 4 hours is 43 degrees Celsius, for 6 hours 38 degrees Celsius, and for 8 hours is 37 degrees Celsius. The average temperature for 4 hours is 43 degrees Celsius, for 6 hours is 38 degrees Celsius, and for 8 hours is 37 degrees Celsius. The turbidity remained within the acceptable range for drinking water. Recommendation: recommends using a laboratory testing method that measures exact bacterial counts instead of just turbidity levels for better evaluation of water treatment methods like SODIS PTSC. This approach would allow for more accurate comparisons between treated and untreated water and assess the effectiveness of disinfection and the impact of different bottled materials. Additionally, increasing public awareness and training for communities on using SODIS and PTSC is important. Future research should focus on improving the durability, cost-effectiveness, and environmental friendliness of these materials for broader application in clean water systems. This is the end of our presentation. Thank you for listening.